Direct and inverse variation equations. For direct equations, the variables, let's say x and y, the one variable will be multiplying times the constant, whether it's x squared, or x to the third. There's multiplication with the constant. For inverse variation, you'll have the x will be dividing by the constant or into the constant. So for direct, as x increases, y will increase. For inverse, as the x increases, y will decrease. So the price varies inversely with the demand. So we'll use P for price, and for demand, we'll use D. Price varies inversely. So we'll say P equals K over D. So D is dividing. Now, furthermore, the price is 250 while the demand is 100 orders. So price of $250 for demand of 100 orders. You'll get 100 orders. And that's K on top. All right, so to solve for K. To solve for K, I am going to multiply both sides by 100. And so this will be a distribution. 100 times this quantity here will give me 1K. And 100 times this second quantity will give me 25 with 3 zeros. Okay, 25,000. So now I can conclude that P equals the constant 25,000 all over D. Okay, for this particular situation. Now, how many units will be in demand if the price goes down to 200? So now the price is going down. So the demand should go up, not the price is going down. So let's find out. So we have P equals, oh, sorry, I'm writing this again. Okay, so the price is 200, and that's going to equal the 285,000 as a constant, and we're looking for the demand, so we'll put the letter D here. So we're looking for demand right now. Now, in order to find demand, I'm going to use an old trick by turning this part into a fraction. We use cross multiplication. When you have fractions across from each other, across the equal sign, you can use cross multiplication. D times 200 is 200D, where 1 times 25,000 is 25,000. Now I'm going to divide both sides by 200, and that'll give me my 1D, and 2 zeros will cancel out, and that'll leave me with 250 over 2, and half of 250 will be 125. So we'll have 125 orders. So now that the price has gone down, you can see our demand now goes up. Okay, let's try that again here. To preserve the volume of a cone, the height must vary inversely with the radius squared. For height, I'm going to use h. The height must vary inversely with the radius. We'll use the letter r squared. Okay, so height, we'll say h equals, so this is inversely, so this will be k over r. Furthermore, r is squared, so we'll put a little second power on there, and this will be the inverse equation that we'll use. So this means as the radius gets larger and larger, the height will get smaller and smaller in order to keep the volume the same. Okay, so we know that the height is 90, k is still unknown, but we have a radius of 2 feet, so 2 squared. Okay, 2 squared is going to become 4, so this is actually k over 4. And we're going to multiply both sides here by 4 in order to cancel out this 4. So we'll distribute it here, and we'll distribute it there. Alright, 4 times this k over 4 gives us 1k. And 4 times 90 is going to give us 360. So now we have that h, let's move that up a little bit. H is now equal to 360 all over r squared. Okay, now we have the actual constant now. Furthermore, What would the height be if the radius is 3 feet to preserve the volume? Okay, so now the radius is going to increase, so we probably need to squash the cone down a little bit. So, question again, what's the height need to be? So height is going to equal 360 all over 3 to the second power. And this will be 360 over 9. And, see, 36 divided by 9 is going to be 4. And with this last 0, so 40. And this is all in feet. So we'll say height will be 40 feet.